Today we will be talking about how you can tune your slow running SQLs. Just a quick recap of what we did in the first Hangout. Let me start my screen share and then so today we are going to look at how one can tune their slow running SQLs while working with PostgreSQL. To do a quick recap, in the last session we saw how one can find out those connections or those sessions which have slow running SQLs, how you can cancel a slow running SQLs, or we also saw how you can log your slow running SQLs. We saw what configuration parameters are important for you to do such kind of things, what PostgreSQL views provide you information about your sessions and your SQLs, and the current execution time of your SQLs. Now let's go a step further and see how you can get execution plan of your SQLs. So this is what we are going to see today. We will be looking at explain plan of the SQLs. Then we will see some basic tips of how you can tune your SQLs, and we'll be giving you some heads up for the next session that we will be holding. So let's look at explain plan. PostgreSQL provides you a command called explain. You can use explain or explain analyze along with your query to see some important information about your query plan. This plan is stepwise execution of your query which PostgreSQL takes, or we can rather say that the way optimizer plans to execute your query. We will further see what kind of, you can also see what kind of statistics are assumed and what steps are involved in the execution. Now let's look at an explain plan and try to see how you can read that explain plan. Now as you can see on my screen, I have a very simple query. The query is select star from a table and a very simple where clause, a very simple filter criteria. And this filter criteria has been executed by the optimizer using an index scan. So you see this green box? This is the operation involved. This is a step. This is one of the steps involved in the execution. You see the orange or brown, I don't know. I'm really confused sometimes about the colors. I guess this is brown. So you look at this brown oval. This brown oval tells you the cost of the step. So this is how you read an explain plan. The very first thing is a step. What is the step of execution? The second thing that you see is the cost that is involved in that step. Then you see a rounded square or a rounded rectangle which tells you about the number of rows which are returned by this particular step. So here are two important things. One is the cost. So this cost is estimated from the cost parameters like sequential scan cost or the random scan cost. These are or tuple scan cost, in memory or CPU processing cost. All these cost parameters that you define inside PostgreSQL.conf. We also see this rows, number of rows. These number of rows are actually estimated by optimizer based on the statistics available in PostgreSQL stats tables. So this again tells you a very important information. If you think that the cost of a query is too high and because of that it is choosing a wrong plan, then you know what to do. You know you need to update some configuration parameters. Same ways, if you think that a particular step is assuming to return different number of rows compared to what it should, then you know that your statistics are not correct. They are not proper. Can you guys see the screen? Okay. So I just got a query that they can't see the screen. So let me do one thing. Let me. Okay. So let me go through these slides. Is this resolution proper? Let me do one thing. Let me start this, and then I go back to, and then I again initiate my screen share, and this time I choose a different screen. And can you guys see the screen now? Okay. So roger that. So this is what I was talking about. So I guess you got all guys might have been confused with what I was talking so far. So this green box is what I was talking about with respect to the step involved or the operation involved. This is what optimizer is executing in this particular step. So this is how you will read explain plan of a very simple query. This oval in brown color, this is what is the cost of this query. The cost is calculated based on various cost parameters that you have defined inside your PostgreSQL.conf. So if you see that the optimizer has used a very wrong calculation or optimizer has estimated the cost wrongly, then probably you need to go and modify your PostgreSQL.conf. Similarly, if you see this blue color rounded rectangle, if you see this, that the estimate of rows returned by this particular operation is wrong, then you know that your optimizer has got wrong statistics. That means that you need to analyze your tables. You need to run statistics update on your tables. So your explain plan already gives you quite a good bunch of information about how optimizer is planning. Let's look at a variant of explain command, which is explain analyze. So explain analyze is little different from plain explain. Explain analyze actually executes the query and gets the actual information as well, and not just estimates. So as you can see, the blue oval, that represents the estimated cost and estimated number of rows and the width of your rows. Whereas when you look at the red oval, that is actual execution time, number of rows, iterations done on that particular data set. And below you will also see, it will also tell you what is the total runtime or execution time of this query. So just to confirm, can everyone see a screen where we have a blue color oval and two red color ovals? So this is what we are talking about, and this is how your explain analyze command will help you. So you can, if you don't have proper statistics estimations available for your optimizer, you will see a vast difference in the estimate and in the actual. So you see number of rows inside the blue oval and the number of rows inside red oval. If there is a huge difference in them, then you know that probably your statistics updation is not happening properly and you need to do something about that. Now let's look at some tips for tuning. These are generally incremental steps, and I myself prefer implementing them in the same order because the order is very important, and we will see why is that important. We will see that in further slides. So the first thing I do is spend some time and tune the query, optimize it, remove costly clauses, remove something which is not required. And we will be looking at some of those tips, how I do that in general. Second thing that I look at is creating indexes. If there is any index which is missing, and I see from the plan that a particular operation can be done more efficiently by creating an index, then I try it out. Before I actually create the index, I try it out and then I create the index. Then second thing I do is optimizing my parameters. So we'll also be looking at some of the indexing tips, and then what I do is I optimize some parameters: sequential page cost, random page cost, effective cache size, etc. These parameters are kind of feedback, or these are kind of inputs to your optimizer, and it is very important to set them correctly. We are not going to discuss them today, but we will be definitely discussing about them in one of our upcoming sessions. Then one important thing that you sometimes need to consider is some resource hungry queries. No matter how much you optimize, no matter how many indexes you have, there could be some costly queries, some OLAP queries which are taking up a lot of resources, or which are running slow because they don't have enough resources. For those queries, you need to change certain parameters either at user level or session or transaction level. So that is another thing that I do sometimes, and PostgreSQL is quite flexible in that respect because it allows you to change these kind of parameters at a user level or at session level or at transaction level, and sometimes even at database level. Parameters like workmem, which are used for sorting, and if a query is taking a lot of sorting space, you can allow just that query to take, let's say, 1 GB of sorting space, and still all the other queries will be taking maybe 10 MB or whatever is your global parameter. So I find PostgreSQL quite flexible that way. Obviously, there are other changes that one should consider, things like changes in your application architecture. Maybe you have to cache certain tables, or maybe instead of firing a query too often, you should cache that data somewhere, or change in the way your application is accessing data, or consider changing your schema design, maybe some denormalization, or maybe changes in the data type, or in extreme cases you can also consider hardware upgrades. But as I said, these are all incremental steps. First of all, try to do all sort of tuning that you can do. Then only you should go for things like application architecture changes or schema changes or hardware upgrades, because these changes are generally more costly compared to tuning your query or compared to indexing. Now let's look at some tips for tuning the query. Few things that I generally look and few things that you can easily observe in a query and go ahead and change. One thing that I have seen a lot of people doing is they always do select star. Everyone always wants to use select star, but they don't really need it. Their application actually needs only certain columns, but they will end up doing select star because that is easy, isn't it? Instead of listing 4, 5 or 6 or 10 columns out of 20 available columns, I can simply say select star. Makes my development faster, isn't it? But that does not make your query faster. Your query becomes slower sometimes, and that happens because of the network I/O and sometimes the disk IO that your PostgreSQL has to do. Like you can see here in these two explain plans. So I have tried to generate an explain plan for a select star query. Very same query, instead of doing select star, I specified two specific columns, and you see an immediate difference. You see that the total execution time has come down by more than half. The reason is quite obvious. You look at the width of result set which is being returned has been reduced almost 1/10, and actual execution time of my index scan has been reduced. So this tells you exactly why you should not do select star. And over and above this, obviously, if your application schema changes, if your number of column changes, your application code may start breaking. So suppose today you have 20 columns and you have said select star, and your application is able to handle that. Tomorrow, if you add another column, it becomes 21, and now your application has not been modified to handle 21 columns. So your application code may break as well. So this is another reason why you should avoid doing select star, and you should prefer to use specific columns that you want to select. Then another thing which I have seen a lot of people doing is they would just go for selecting everything. Now when I say everything, it is not with respect to number of rows, not with respect to number of columns, but it is with respect to number of rows. Generally you don't need all the rows, and even if you need all the rows, your application cannot handle all the rows at the same time. Mostly in inquiry screens where you need a lot of rows, your application first thing, if it is Java or if it is .NET, it cannot store all the rows, everything in your record set inside memory. So it will make your application resource hungry if you are selecting all the rows. So it is not just a performance consideration on the database side, but also a consideration on your application side or on your app server side. Plus, when you show it on screen, your viewer or your user cannot see all the rows at the same time. He has to scroll through a lot of rows. So generally a very good practice is to put up all your filters in your SQL query, fetch only what you need using where clause, limit your record set using limit or offset clauses. Offset allows you to skip certain number of rows, and then limit allows you to select particular rows or n number of rows. So this way you can implement a rolling inquiry screen very easily, and in that case that enhances your database performance, enhances your application server performance, plus gives a better visibility and better user experience to your end user. Isn't that wonderful? One tip and that gets you 3 things done. So let's look at an example. When we look at this example, I have fired the very same query, but instead of selecting all the rows, I am trying to limit the record set. I am trying to limit the record set and make it 100 instead of selecting everything. So you see that immediately from almost 11,000 rows, my number of rows have come down to 100. And what this means, again, less number of data, less number of network traffic, less amount of IO. And because of this, you can see that total execution time has come down drastically. It has come down by more than 100 times. Isn't that wonderful? Plus, your application now has to deal with only 100 rows in memory. And when your user sees, he looks at only 100 rows, and when he wants next set of 100 rows, he will click next, and your database will perform another select query. which will be offset 100, limit 100. So this way you can optimize your queries and user experience as well. Third thing which I have seen a lot of people doing is unnecessary sorting. Now when I say unnecessary sorting, sometimes you need sorting, but sometimes you don't. Now when is that sometimes? You have limited number of data to play with and you want to show it on screen, but your application has sorting feature, and this sorting can happen on any of the columns. Let's say you have date and amount fields to be shown in transaction details, and user has flexibility to sort it either by date or by the amount. In that case, the sorting should be left to the screen, or it should be a client-based client-based operation on the client end. It should not be done at the database end, because does not matter how you are ordering it, the user can choose a different order. So avoid order by clauses as much as possible. Use them only when your application and your end user requires them, because whenever you do order by, there is some sorting memory required. When this sorting memory is required, PostgreSQL tries to allocate that from work mem. But if work mem is not enough to accommodate all the sorting data or all the data set which needs to be sorted, it will spill over to disk. Now when sorting goes to disk, there is IO involved, which slows down your query. You can obviously overcome this by setting your work mem to an adequately high amount of memory, but that could be an overkill sometimes. So try to avoid order by clauses as much as possible, but when your business needs it, obviously you cannot avoid them. Now let's look at an example here. Now when you look at this example, we have said order by account balance, and that query has taken 57 milliseconds compared to a query without an order by clause, which has taken around 12 milliseconds. So this is around 1/5 of the execution time with order by clause. So there is an advantage of 500%, right? So try to avoid sorting, and in this case we are lucky that the sorting method is quick sort and it has accommodated everything within memory. Nothing has gone to disk. So imagine if same operation would have happened on disk, this might have been even higher. The runtime or execution time could have been a, a second or half a sec or easily around half a second, since it would have involved another IO operation. Now, many times people want to do an update, and they want to do an update from another target table, and this target table has some data that you either need in the where clause or you need to set your columns to that data. Now this makes it a very complicated query that you can see on the screen in red. So you can see I'm trying to set a target table. I'm trying to set values in a target table. I'm trying to set values for two columns which I have got, column to update and column 2 for update. And you can see I'm trying to select data from another source table, and I have to write a subquery, in this case a correlated subquery, a correlated select subquery inside my update. Plus I have to ensure that I am only updating those rows which I need. So I need a third subquery. Now you imagine what would be the plan of such a query. This query can be easily translated into a much simpler form, because very few people know that PostgreSQL supports a different form of update statement, which is update from, and you can use this from table, which is your target table, sorry, which is your source table in the from clause. This is similar to a join statement. You're trying to join two tables and trying to update the target table from the source table, and you have pretty much a join condition here which joins your source and target tables, and based on this join criteria you will get certain values which you are assigning into your target columns. Now let's look at the explain plan of the first query that we had. For simplicity, I have avoided using the exists clause here. I'm just trying to update all the rows. If they do not exist, it will be updated to null. And let's look at that. So what you see here is there are two subplans. These two subplans belong to two different subqueries, and these two different subqueries are cumulatively getting executed in almost 22 seconds. And there is a lot of index scans. Even though my columns are indexed, even then this is quite a costly plan. Now let's look at update from version of the same query. So you see this query looks more complicated because it is more verbose. There are more operations happening, but you see there is a hash join. Like I said, there is a join condition. There is a join happening between the target and the source table, and this join condition is joining our columns, our target and source table, and there is a join memory or the sorting memory which has been used here, and the total execution time has dropped from 22 seconds to 1 second. That is a huge benefit. Plus my update query looks much more simpler. Now imagine in this first example we had two subplans because we were updating just two columns. Imagine what if we were updating 3 or 4 columns. The increase in execution time or the cost of query would have been exponential. It could have been 44 seconds, whereas over here it would have remained more or less same because there is just one hash join happening. There are not multiple subplans, which makes our life easier. Now this is my favorite tip. This is what I do, this is what I share with developers all the time. Sometimes we try to do things, we try to make things simpler, and we try to implement business logic as it is. Like we want to check all those people whose salary would become $1,200 if I add $200 to their salary. So these kind of queries, people try to implement the logic as it is. Another example is I want to see which are those employees who are hired on a particular date, and my hired date is actually a timestamp column. So in that case, the ideal way would be to truncate the date time part of that column and compare it with a date field or a date literal. Now these kind of queries will not actually use an index scan. Your PostgreSQL will not be using an index which is created on higher date time, or in case of first query, an index which is created on salary. And if you would apply a little more aptitude in this, if you put in a little more if you try to go back in time and try to apply your high school mathematics, simple high school mathematics, which says any equation is same when you shift your left hand side operands to right hand side and inverse the operation. So that is what I have done. So you see after the arrow, the operations in blue marker or in the blue ink, it is same as the previous operation, but I have changed it. I have shifted the expressions towards literals instead of using them with the column. So you see, instead of checking salary plus 200, I'm checking literal minus 200. Same ways, instead of checking or truncating the time part from my date, I'm trying to do it other way around. I'm trying to append timestamp to my date and checking between an interval. Now my second form will actually be using the index. It will do a range scan on my indexes, which is great, which will reduce my query time, and I don't have to create another index which is based on the expression. And this is pretty simple. Now what happens when all these basic tuning tips does not help? What happens when these basic tuning operations do not help you out? Still your plan remains costly, or still you have not been able to optimize it to the level that is required by your SLAs. What do you do in those cases? So the very first thing that you can do is do an explain plan and look for usual suspects. Read through that plan and try to see which is the most costly operation. So like you can see on my screen, the highlighted operations are quite costly. The cost of that particular operation is 66. It is 66 as per the cost defined in my PostgreSQL.conf. And now I know who is the culprit. Now I can try to fix that. I can try to either tune that part of the query, or I can go ahead and see if any index will help me. So that is what I have done here. I have tried to create an index on one of the columns which is involved in this exists clause, in this hash join. So if you see in the previous screen, I have a hash semi join happening. So what I do is, okay, there is a sequential scan happening on pgbench tellers for a criteria which involves branch ID. So I create an index on that, and now I see that sequential scan, which was costing me 66 units, has been converted into an index scan, which is almost 8.5 units, which is much more faster. And my execution time, if you look at, has been dropped down. Well, the first query I did not actually do an explain analyze, so I don't have the execution time as such, but I can see the cost has been dropped from 75 to 14, which is almost 5 times of difference, which is great. So when you do indexing on your tables, when you go ahead and create indexes on your tables, you need to remember a few things, a few facts, how indexes work in PostgreSQL. PostgreSQL has a feature called index only scans. So if you have a query which can be executed by scanning all your indexes or all available indexes, PostgreSQL will not even touch your tables. It will simply fetch data from available indexes. Something called index only scans is what you will see in your explain plan. Another great feature that PostgreSQL has is intersection between two indexes. Now previously we saw there is an index scan happening here on branch ID, and if I had one more index on bank balance or branch balance, in that case PostgreSQL would have created an intersection between these two indexes, and then it would have fetched data. So PostgreSQL can do intersection between two result sets from index scans. So if you create individual indexes, that can help your queries. PostgreSQL can use filter indexes, which is quite a great feature which I don't find in a lot of modern day relational databases. Now, how these filter indexes would help you? For example, if I created a filter index and I said that create index or index branch IDs where bank balance or branch balance is equal to 1000 or 10,000. So in that case, this particular query would have been fetched directly from that index. Okay, so this is how your filter indexes can help you. Then comes pattern searches. You should be careful that certain pattern search can use indexes. Like if you're doing a like search where you're beginning with certain alphabets, your indexes on that particular column will be used by PostgreSQL. But if you are going to use an a like clause where the pattern is in the beginning and alphabets are at the end, or your characters are at the end, those queries will not actually use your indexes. So you should be wise, you should be careful when you are using or you are doing pattern searches. You should know which expression will use index and which will not use index. PostgreSQL has a feature for expression or function based indexes. You can actually, if you recollect, if you recall, when we were discussing the simple high school mathematics, what we did to simplify our operation or to make it much more efficient, we shifted the whole operation from columns towards literals. What we could have also done is create an index on this particular expression. If you know that your database is all, your application will always query based on this expression, then you can actually create an index on the expression itself, which makes your life much more easier. But one thing that you should remember is indexes are not a replacement for a flawed schema design. If you have not designed your schema, your tables, your normalization is not proper, or you have over normalized your schema, indexes are not a replacement for that. Or if you have written a query in a very bad way, if you have a query which has got a lot of sub queries which has not been optimized properly, and you think that by simply creating indexes you can optimize or you can enhance the performance, that is wrong. Indexes are not meant for that. That is why I said initially I prefer to execute these tuning steps in this particular uh, order. First thing that I do is tune my queries, and only then I go for looking for any indexes, looking for a possibility of new indexes. And before even writing your queries, you should know what is your business requirement and what kind of queries are you going to expect, and accordingly you must design your schema. So in the next hangout, as I said earlier, in the next hangout we will be discussing some basic configuration and tuning techniques. We'll look at some of the parameters that we discussed earlier, how you can tune them, and what parameters you should tune at the global level, what parameters you should think of tuning at the session level or at the user level. So with this, we end this session. Let me go back and see if we have got any questions. It is still loading the question answers. If anyone has any questions, please put them across. We'll be happy to answer that now, or in case you are watching this as a recorded video, you are watching this on YouTube, or you are going to watch it on our website, or you are going to watch it uh, on or you are going to watch this on Vimeo. We are going to upload this on Vimeo as well. Then in that case, you can go and comment. You can put this as a comment, and we would be happy to answer your queries. So is the date for next Hangout announced? It is not yet announced, but we are planning on doing this more frequently. We have seen quite a good response on the previous Hangout and even this Hangout. We have seen people are liking this, and we are gonna do it in another 15 days or a month's time. And stay tuned, and please let us know if you are one of the experts from PostgreSQL community, or you are a PostgreSQL user and you want to share something that you have learned and something that you have tried in PostgreSQL. You want to share that with other users. You can use Postgres Hangouts as a platform to do that, and will make you famous as well. So people will be watching you live. So please drop us an email if you want to, or put that in comments on our website if you want to be one of the speakers in an upcoming Hangout. Yeah. So